when I've come to a couple basketball games, I hate that we have to stand. I would much rather stand.
And don't sit in your parents.
Yeah, no, this is my thing. Usually when we stand.
All right, what questions do you have about 6-6? Anything on 6-6?
Number 3.
So number 3 here, you take the 750 joules that they gave you. You need to convert that into kilojoules to be able to work with this unit that they gave you in the problem.
Oh my God.
Okay, so I've got that converted into kilojoules. Now I'm going to cancel my kilojoules out, and that goes into moles of reaction, because remember, this is kilojoules per moles reaction. Then I look at my coefficients. So for every mole of reaction I go through, I have 3 moles of this EF. And then you just multiply through and divide. What's the question on 3?
I was just confused. I forgot to put the kilojoules.
Okay. So somebody said everything. Did you look at everything, like with the answer key, or are you just saying that vaguely? Do you have questions on number 1? Do you have questions on number 2?
No.
What
I got 2.4B. 2.38 moles is used because it's limiting, right?
Yes. That's why I have, see where I have LR here?
Why is number 2 negative? Oh wait, never mind.
Because it's negative.
I had a question why one of them was negative.
I have question number 5.
I don't know which one it is.
I heard somebody say 4B. Does somebody have 4B, or did I just miss here?
Oh no, that was me. That was Ellen.
Okay, so the enthalpy per mole, you have to figure out how many moles you had. So you're going to use, this is your, did I reverse those? No, 0.1 liters. 1 mole. What did I do there? I think I reversed those when I wrote that down. This should have been the liters, and that should have been the moles, but you multiply them together anyway and come up with the same answer, so it's fine. And then if this is joules, right, per grams degrees, or no, joules are up here. That would be joules per mole reaction. So then if you wanted to know for the mole, you would have to divide it by 0.1 to be able to get it in per mole. And then C, they wanted to know how much heat would be evolved from this many moles. Well, this is moles per reaction. So if we cancel out our moles, that's how many kilojoules you end up with.
I have a question on number 6 too.
Anybody on 5? Okay. 6.
Where did you get the 40 grams from?
Where are you seeing 40? Oh, here. That's the molar mass of an AOH.
Okay. Wait, I have a question on 5 actually. Why is it negative? Because it says positive. I think that's
Oh, you want me to go to 5 here?
yeah.
Okay.
It says it's positive 600.
Yeah, I must have screwed up. Oh. Oh, I see what they're doing here. Okay, I see what they're doing. This is a plus sign here. They're not saying delta H equals that. They're saying that this is a product. So if heat is a product, then that makes that exothermic. So that means that I need to change this.
No, but I was like.
Well, she shouldn't when I'm
Then I was like, that's
when
not
I'm
that
screwing
much
up.
better than me.
Lippy is not smarter than you guys. No. Do you know when I took calculus? Exactly. Well, that stinks. It's only going to let me move part of the circle. Thank you, Yesenia. It's okay. Yeah.
Calculus for math.
No, what, don't try. Just don't even. No, you can't recover from this one. It's not gonna happen.
I love you too. Out of all the science lectures I've ever had, I love you the most. And I always will. I love everyone.
Oh my goodness.
I love you.
All right, is that better? Okay. Does that make sense why this is a product? I was thinking that it was written differently. That's where my brain was at. I was thinking that it was written like this, and that's something we have to be careful of, okay? When it's written like this, where they say delta H equals this, that means that that's going to be a reactant over here. It's going to be on this side, okay? And that's where my thinking was flawed there and where I kind of fell apart with this one. Okay. Does that make sense? What happened there? All right. What else on, I think we were supposed to be talking about 6, but you guys sidetracked me on to back to 5, which was good. 6 is good? Okay. What about 7? Okay, there is no 8, so we're ready to move on to 6, 7. All right, any questions on 1? How about 2? Because they gave me grams and I needed to get it into moles. The molar mass of NH3 is 17.
Actually, this one pretty good. Well, I know. I can add on.
All right, what about number 3? No. Number 4, I didn't have down because I ended up doing it on 2 different sheets of paper. There's the answer to it, and I can go through. This is my work for it. So that's why it didn't end up like getting copied on there because I didn't have enough room. So anybody not get negative 93? Need me to go through it?
Wait, I don't know what I did either. Why don't you have like the single symbol?
Because this is somebody else's work, okay? So
What? I got negative 350. Yeah, that's what I got. Yeah.
Okay.
I got 93.
That's what I got too.
All right.
I think
So
it's other diagrams are drawn differently.
I'll show you about the I'll show you about like how we ended up with that and how they did their thing and why they don't have it over there. Okay. Let me get this bigger here so we can draw on it. I'm just going to draw on this guy because that I have a slide. So this is my H, my C, 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 double bond, C, H, H, H. Nope, that's not right. That's in the wrong spot. My bad. H, 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 H.
Oh, I did have a double bond.
I got my BR here. Okay. So that takes care of that side. And is that balanced? Yes. Okay. And then over here, I end up with BR, C. I got 4 C's in a row. BR coming off of here. Got an H, 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 H. And I think that's it, right? That's the structure drawn. Everything's good there. Okay. All right. So over here, I have 1, 2, 3, 4, 5, 6, 7, 8. CH, I've got 8 of those. Okay. I have 2 CC, and I have 1 CC. I have 1 of those, and then I have a BR. I have 1 of those. All right. On this side, I have CBR, and I've got 2 of those. I have 1, 2, 3, 4, 5, 6, 7, 8 CH bonds. I have 8 of those. I have 1, 2, 3 CC bonds. Okay. Now, why didn't they have CC bonds over here? What they did was they looked on both sides and they went done and take this down to 1.
No,
Here,
what I did is I forgot the double bond.
gone, and gone. And by doing that, it reduces how much math you have to do. Does that make sense?
So they cancel out.
They're going to cancel out when you subtract them, right?
Yeah.
So you're saving yourself time by not having to do all that extra calculation. All right. So then if you look up the double bonds, this is a 614 over here. Your BR is what? Is that 193? I don't have a 193. Okay. My copy here is not great. So this is 807 on this side. And then over here, we have 2 times 276, which comes in at 5. What is that? 2 times what? Is it 276? So that ends up being 552. Yeah. And then I have 1 here at 348. So if I add those together, they come up to be 900. And then 900 and 807, bonds broken minus bonds formed. That ends up being another negative 93 kilojoules. Good? All right. Any questions on number 4 before I pop out of here and go back over to where I was at?
So proud of me. I nailed this lesson.
Good.
So if you want to do a whole test on this, I'd gladly take it. When you want to make the final, make the final, no problem.
All right. Any questions on number 6? How I got this?
Oh, you can put the numbers into the reaction. Okay. Now I know how to do that.
Okay.
I was just confused where you were pulling
Because there's 2 of these from this coefficient right here. See that? All right. Anything else? Good, Jacob?
Not a big, like, I
Okay.
would just,
All right. Moving on then to enthalpy of formation.
I think this is better than this stuff. With you? No, this is what he says. Look, doesn't this one says you like theoretically you can make up something. He invented it or something. But I'm like, okay, this is
No, he discovered it from that.
no, he
All right.
made it up.
MK, I'm recording this. So
You didn't have to say it was me.
please.
Why? What did you do?
Somebody's watching me. I think they assume that
I know she swears up a door over here.
no, fucking just call me out on the recording.
Feel like I'm
No,
a sailor on a ship sometimes, and
Does anyone watch these?
I know Matthew and Jaden plan to. So
Why did he watch it?
I thought you meant like to review for the test they watch it, so that's why they get test scores and all of us.
If you really watch some of those videos, you would not you waste all the time.
all right, here we go. Bond breaking is endothermic. Energy is getting transferred to the surroundings. Bond forming is exothermic. We talked about that. Standard enthalpy then is abbreviated delta H prime. This prime tells us that we're dealing with something called standard state conditions. That means that we have 1 mole and so we're going to end up with 1 mole of reaction. We have 1 ATM for our pressure, and our temperature is at 25 degrees Celsius or 298 Kelvin. This is considered room temperature. So if we were to do things at standard conditions, where we have the standard temperature and pressure, which is 273 Kelvin, that's 0 degrees Celsius. You don't typically work in 0 degrees Celsius temperatures, okay? So that's why they tend to have these things as standard. With these standards, they tend to have the values at that 25 degrees Celsius. So we talked about the bond energies. Now we're going to be talking about the enthalpy for reaction by looking at the energy of the molecule as a whole, not by just breaking those bonds, but as the molecule as a whole. And we've got tables that we look at for that. So the enthalpy of formation at a standard state is the energy change that occurs with the formation of one of these. So when you were looking at forming those things from their individual elements, like if you had hydrogen and you had oxygen and you put them together to make water, or it would probably be, that's probably not the best way to draw that. I would do this, 1/2 H plus H2 plus 1/2 O2 yields this, okay? These are the individual components that we have going in to make this up, all right? So these, when we're looking at these, the enthalpy of reaction, so H prime, delta H prime reaction is the energy change that occurs for a reaction. The different subscripts of a reaction, or F, which is formation, indicate the type of enthalpy we are measuring. So if we're doing stuff like we had last night, it'll say energy of reaction, delta H reaction. If we're looking at today, it's going to be delta H formation. So this would be like this, where the water is forming. Anytime you see prime, you need to verify that you're working with the elements in their standard states. So if they have delta prime here, you need to read the problem and make sure that they haven't deviated from that. Okay? Because if this is given at prime conditions and they say that you're at 273 Kelvin, things are going to change. That makes sense? All right. So when we are doing this, delta H reaction is going to be products minus reactants. So when we are working with these, the enthalpy of reaction is equal to the sum of the formation of the enthalpies of the products minus the enthalpies, the sum of the enthalpies of the reactants. This is opposite of what you've been doing. You were doing broken minus formed. Now we're flipping that around on you. So make sure that you're accounting for those moles in the balanced equation. And most textbooks, including the one that you have sitting at home, probably in a stack somewhere off to the side, have that data information for you. What I have done is in your note packet, I have also copied those tables for you, so you don't have to go and find that in your book, okay? So you need to get used to looking these up in that chart. Now, when you look at that chart that I gave you, I don't have in front of me, which is not good. You're going to be coming back to that chart in Unit 9 as well. So keep that in mind. That chart is not going away. I need to find that somewhere. Okay, this one isn't exactly like yours, but it's close. I don't like that one. Hold on. All right. So okay, here we go. This is a little better. So
I'm going to bed at 9.
when you are working on these, notice that that chart that I gave you, you've got 3 different things here, okay? This is delta, and I don't think this is going to let me write on here. I wish it would. No. I don't know why. There we go. Maybe it's going to let me now. This is your delta. Seriously? You're just going to do dots on here, huh?
Can I use this? Oh, damn. I just erased it.
No.
Add signature.
It won't. It's like a digital signature. Like it would be an image of my signature. So I'd have to import an image.
Are you trying to write on it?
Yes.
Well,
Come on, Allie.
knowing my technological whiz.
This is going to be delta. So your delta triangle S, or not S, H for this column. So you've got enthalpy. Write a triangle and write a capital H here. So delta H for enthalpy. Entropy is delta S, which we will get into when we get into chapter or unit 9. And didn't I give you a chart here?
Yeah, I didn't have a We don't have the word.
Right, I understand. Oh, you have the symbols already.
Oh.
Okay, good, good, okay. So you have the symbols right in the words then. Okay? Enthalpy is delta H. So where you see delta H, that is enthalpy. Where you see delta S is entropy.
I'm not seeing the same thing as on the screen. Where is it?
Where is delta?
It's not exact. My chart here doesn't look exactly like your chart.
Oh, man.
Oh, it's okay.
Just drawing the delta.
Where it says enthalpy, write in delta H, or where it says delta H, or where it says capital H, write in enthalpy. Enthalpy. Do you have a capital S there? Write in entropy where it says S. Do you have a big G?
Yeah.
Write in Gibbs free energy.
The reference between the ones that you Gibbs free energy. Maybe one that's like, no, exactly what you write. Yeah. What? Okay. Yeah, precisely. No.
Now, these values for enthalpy, which is all you care about right now, the values for enthalpy are in kilojoules per mole. So kilojoules per mole is what you're working with when you're working with this. These other two columns you are going to ignore for now. You will need these when we get into Unit 9 along with this. You're going to put all three of these together in Unit 9. But right now, all you need to be concerned with is this. Okay? Notice on your chart that these vary by what state of matter or if it is aqueous or not. So you need to be paying attention to your reaction and the state of matter of that reaction.
We don't have
AQ.
No, I mean like our first substance.
Several of them have AQ. Look down the chart here. You see where it says AQ at the end for state of matter?
Yeah, no, I'm talking about like we don't have like silver.
I understand. My chart is different than your chart.
How'd you get a space in there? It's on the last page. Yeah. How do you get it? Yes. Right here.
Yeah, we just sort of
It's that. It's always different. So far.
All right, here's your chart. Here's your chart. Here's your chart. You guys are not flexible at all with being able to like handle moving from one place to the next. So let's try this. All right, here we go.
There we go.
So like I said, you will have situations where you have different states of matter and sometimes aqueous, okay? If it is a solid and the single element, its enthalpy is always 0. Okay. When it changes into a gas, then it's different. But you can see here where we've got aqueous, the values change. Okay. Do you see how to read the chart? Okay. So I have aluminum, barium, all the way through bromine here. And then on this chart, it takes over from there. Okay. I just couldn't get everything all on one page. So this is delta H. That is what? Delta G is gives free energy, and delta S is entropy. Okay. These two you do not use until unit 9. This is what you're concerned with right now. Okay. So that's where we're going to be getting our values from, is that chart. So going back over here, we're doing the combustion of propane. We're trying to figure out if that is endothermic or exothermic. All right. Assume standard conditions, it says, which makes life a lot easier. So the first thing we have to do is we have to know what the formula of propane is. Where's propane? C3H8. So this is C3H8, and at room temperature, what is propane? It's a gas. Good. Okay. We're combusting it. So what is our other reactant? And what is formed when we go through a combustion reaction?
Water.
Carbon dioxide and water. This is a gas. This is going to be a gas. And this also is a gas. All right. Now we need to balance our equation. Is that right? Is that a 4 here? Wait a minute. Okay.
Two. Not mine. No, there you go. Sorry.
All right. So this is going to be the sum of our products minus the sum of our reactants. It's a sigma. I don't know how to draw it. You can go up. You can look and see what it's supposed. This is what it's supposed to look like. Okay. Okay. It's whatever you guys want to do it. Okay. It's the sum of is what it means. All right. So now we need to find these values in our chart. So you're going to go to your chart. You're going to find CO2 in your chart.
Hold on. Found it. Negative 393.5.
Right. Now, find that in your chart. That's 3 times negative 393.5. Now, be careful with that guy, because right below him is the aqueous version of it. So you've got to look in your chart. Did you find it in your chart? Do you see what I'm talking about? Okay. Okay. But you have to be careful, because you've got to be able to distinguish between that, the gas, and the aqueous. What are you looking under? Okay, it's probably under oxygen then. So if you don't see it under the first one, go to the second thing in the formula. Okay? So now remember, we're bringing all of this together. So we're going to add that to the water. And again, be careful with the water because this is the gas. Make sure that you're picking the right one off of that chart. Okay, now you're going to go and you're going to find your reactants here. Okay, so I'm going to find my propane as a gas.
Found it. It's negative 103.5.
Oh, I found that one. P38.
Oh, I see. Got it. Negative 103.85.
Oh, there you are. Yeah, that's really good.
5 times what? What is oxygen? What phase is oxygen? It's at 298.
0.
Okay. And if that's the standard state, then that's always going to be 0 if it's a pure substance. All right. But you can look it up at the chart again if you need to, because it's going to be on there. It'll say 0. Did you find oxygen and find O2 on there? You good? Okay. Now we add these together. And you should come up with delta H equaling a negative 2043.85. And that's kilojoules per mole. For your answer. Okay. All right. Everybody cool with that?
Is there a difference between?
That means that it's at standard conditions. Yes, it's exothermic because it has a negative value here. All right. See if you can figure out the enthalpy of reaction for this. Your final answer for that guy. For the first question, you should end up with you don't want me to tell you?
Yep. No, don't. Yeah. You can solve it backwards.
She can solve it backwards.
Doesn't that help? You can't even solve it forward. She can solve it both ways. I can't solve it forward. I can solve it NaHCO3.
I'm not finding it.
You guys are rapid.
What is that?
Hold on.
Oh, I found it. It's under sodium.
There's 2 questions here, by the way.
Yeah.
Oh, it's fine. And negative 11, 30.
What is that?
Less than negative value.
Oh, I'm doing it the wrong way. Oopsies.
Well,
Because you can't do NaHCO3.
You can just find the numbers.
No, she put it on the other side.
Yes.
Yeah, that's what I said. Thank you, Willa. Thank you. Oh, yeah.
Oh, I didn't think I had.
Well, then why are you so rude? You're being rude to me. So I just, you know what my philosophy is? You get what you bear. What are you talking about over there?
I'm saying, all anybody else in the world is in the chapter.
Yeah.
So how can you tell which side is going to form and which side is going to form?
You're not, this isn't broken minus formed. This is enthalpy of formation values. So when they give you these delta H prime values, that's also always going to be a formation reaction. So that's always going to be your products minus reactants.
I got it. I got it.
Or do you remember when he was like, looking dressed
I did
out,
something
he was
wrong.
like, you guys don't get it?
Never mind, I
Don't
got
come
it.
trying to me, because I showed you the way. And I was like, yeah, but it was like the whole class that was looking at it. But he's like, I look at you guys too, you guys are horrible people.
The whole class was looking at you.
No.
I was gonna say that's embarrassing.
Remember when we were doing that thing? And then that-
He's already good. I got 150.
And we just started going back
What?
and forth, I was like, what? What?
She has one for conference.
It's because Matt was like, this.
I got 330.
It was
377.
how do you solve 100 and that is like.
Alright. So,
Why, yeah, if you don't know the answer,
So,
like.
that's
this is
what
what
I'm
we
doing,
watched
so-
that.
negative 950.8.
He's just playing.
Forget about like double negative and stuff.
Maybe.
And just put it in your calculator the way that it rings, so you
Yeah,
don't have to
honestly,
like count up the
we could do
negatives
that.
that way.
I didn't know what else to do. So, it was funny in the moment.
It was just.
Sorry that you're not cool.
Oh. I see where I want.
All right. Did you get this for the answer for the top section? Okay. Have you started the bottom section? It's going to involve dimensional analysis.
Do you know the molar mass of baking soda? Give that to me.
Guys, you got it right.
You don't act like you know what you're doing.
I really did it. No, you didn't.
Did you get this set up right? Oh, I gotta give you that. Do Monday, but you might want to get started on it tonight because you're not tonight and tomorrow night you're not. You only have one section each day, so it's not quite as much. So get started on this.
Did it.
All right, and then if we're doing this, you would have this is 1 mole per gram. Here, you've got 1 and 2 moles of these for every 1 mole of that. Right here's where I got the 2 from. And then 1 here and 135.6 here. Okay, makes sense? All right, 5/8 is due tomorrow, and you can get started on your progress check. Progress checks due Monday. Thank you. Just
So-
set it behind me and I'll take care of it in a
There's
minute.
one that didn't have like a thing for it. This one.
I ran out.
Yeah.
Oh, okay. Yeah, just throw that away.
Realize all of them are good.
Thank you.
Where are you at right now, Al? I'm right on the edge.
Okay. I'm gonna. It's in the same spot you had. And I'll be right back in a minute, guys.
Really?
So, for those of you who are going to be, or if you want to right now, it's up to you, sticking with me for the rest of the year, that's the classroom code that I have. And I have in there, I have, if you go to the classwork and everything on it, I videotape my classes every day. So you will always be able to go in and be able to watch the lecture for stuff. So if you want to join that and you're like, oh my God, I don't remember how to do sig figs, it's been too long, and you want to get ready for the exam, go to that time period, when we were doing chapter 2, and my videos are all out there. So for those of you who are kind of like, oh my God, I don't remember how to find an average atomic mass and stuff like that, that's going to be on the final, I have those videos available for you. If you go to each individual day, there's different videos out there. So it might be helpful for you. If you end up with Common next year or next semester, then obviously you're going to have to join a different class at that point. But most of you are going to be staying right here with me. So let's see here. I've got oh, you were gone yesterday, right, honey? Oh, I've got 2 people that are virtual too. I'm supposed to bring them in with these meets. I'm gonna stop recording this. Stop